Altitude 4200. Houston, you're a go for landing, over.
On the 20th of July, 1969, the world watched as Neil Armstrong and Buzz Aldrin took their first steps on the lunar surface.
That's one small step for man, one giant leap for mankind.
This unprecedented engineering, scientific and political feat is seen by many as one of the greatest achievements of all time.
It's fantastic! It's unbelievable! You should see the crew that are filming me, what they're up to.
But how did the BBC report the lead-up to this astonishing achievement?
Oh, my godfathers, we're going right over to the left. I feel as I'm turning clean over at the moment.
It's called a lunar track. It's been specially designed, just like the real moon vehicles, to go over obstacles. In a minute. Oh, you all right?
In this special Sky at Night, we've dug deep into the BBC archives and found some footage that hasn't been seen for over 50 years.
You're sweating furiously now, but were you really uncomfortable in it?
I was a little hot.
And shared it with those who were inspired.
These zero-G flights are the best part of the training.
Those who remember.
There were crowds of people outside shop windows that were transfixed.
At that point, if all goes well.
And even those who reported it at the time.
We're dealing with the advanced technology of going to the moon with Stone Age graphics.
This is the story of how the BBC put a man on the moon. I've invited some special guests to BBC Television Centre, where much of this early footage was recorded, to watch some of the clips we've gathered and get their reactions to how the quest for the moon was reported in the very early days, long before the triumphant lunar landing. I'll be talking with Helen Sharman, the first British astronaut, to see how accurate the predictions about space travel were, and with James Burke, who covered many of the Apollo missions for the BBC, about his experiences reporting on one of the biggest science stories of the 20th century.
And where are we seeing this first clip?
Oh, it's just me on the screen here.
Oh, over there. Holy cow. Oh.
But I'll start with space scientist and old friend of the Sky at Night, Professor John Zarnecki. John, I'd like you to watch this first clip and see if there's anything that's familiar to you.
Well, that music, of course, yes. You could never mistake that music.
For the modern universe. And it's thought that this was sort of the prequel to the Sky at Night.
Gosh, I didn't know that. And Raymond Littleton, of course, a big name of astrophysics from the 50s.
Tonight, we're going on a journey to the moon. We're in a rocket in a remote part of New Mexico. Now we're off. There you see the Earth receding from us.
Well, now I think we've pretty well arrived at the moon now.
Yes, I think we're getting fairly near. And here we are actually landed in a lunar crater. The ground is a deep sea of fine dust into which we would sink and be swallowed up. Our only hope of getting about would be to stick to these mountainous crater walls.
Well, that's half right, isn't it? I mean, the moon is at least partially covered in places by dust or regolith.
Yeah, but I guess they thought that if you landed on it, you'd sink in.
Yes, and that, of course, was one of the big worries in the early days. So, you know, maybe travel to the moon would have been practically impossible.
So, John, looking at this image, what does it say about our knowledge, or, dare I say it, the lack of knowledge that we had of the moon at the time?
You're right, it's more lack of knowledge.
Yes.
But of course, our knowledge of the moon up till then was based on ground-based observations from large telescopes on the Earth.
Yes.
So,
But yes, this
you
sort of
know,
detail you can't see with
you'd
that.
see the resolution, the finest detail you could see would be kilometres. You know, so though our knowledge of the large-scale structure was perhaps okay, anything detailed of, you know, fine scale of what you would see if you landed and walked around was vague.
So looking at the topography, at the sort of the scene, we've got some fairly jagged mountains, hills.
Yes, and I think that's, you know, from what we now know, the topography is a bit more undulating, and I don't think we generally see features like that.
Yes. But I guess this was an early view at what they assumed the moon might look like.
Absolutely. And, you know, I mean, a lot of our knowledge was, as when I was growing up, it was from comic books, you know, Dan Dare, and you know, this is the sort of picture that you would see that I remember in the comic books.
Yes. Yes.
So comic book planetary science.
But within 2 years of that broadcast, the Russians put the first satellite, Sputnik 1, into orbit. And suddenly, the idea of a lunar landing was more than just a flight of fancy. Within a week, an episode of Frontiers of Science took a serious look at the prospects of travelling into space.
Tonight, man stands on the threshold of outer space. Since the Russian satellite was launched a week ago, it's covered some 3 million miles. Well, does this now mean that space travel is a practical possibility? Can man build a vehicle that will take him not only to the moon, but to the planets as well? And having built one, can he equip himself to survive in the emptiness of space? And in any case, what practical benefits can we expect from man's first big step away from the Earth? This is what Frontiers of Science looks into tonight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I think that's a Skylark sounding rocket.
Sounding rocket, yes.
Yeah, that's what I did my PhD on.
So what were the capabilities of these?
They would give us about 10 minutes above the Earth's atmosphere. And so I was involved with X-ray astronomy.
Oh, right, yes, which can't be done from the ground.
Absolutely,
because it's absorbed.
Yes, I mean, luckily for us, the atmosphere absorbs X-rays.
Yes.
But if you want to look at energetic events in the universe,
you need to be up there.
You have to be up there.
Obviously, there are great technical engineering feats that are faced or have to be faced by engineers like Dr. Alex Baxter, who was formerly a professor of propulsion at the College of Aeronautics, Cranfield, and is now chief executive of nuclear engineering and rockets at de Havilland. Now, we always seem to assume that to get into outer space, we've got to use rockets, Dr. Baxter. Now, why exactly have we got to use a rocket?
Well, the answer is quite simply that the rocket engine is not only the most powerful type we know, but it's the only one that will work outside the Earth's atmosphere. And the reason for that is that it carries its own oxygen with it to burn with the fuel, instead of trying to use the oxygen in the air as other types do.
How big would it have to be?
Well, that would be a very heavy rocket. Perhaps that one would weigh something like 1 ton of takeoff weight for a pound, 2 pounds of payload. But we can overcome that structural problem by using a rocket which carries another rocket at 2 miles a second, drops away, and the second rocket will then go forward at another 2 miles.
I love those graphics.
This was sophisticated graphics by the standards of those days.
We could get, and I think that if we considered it in relation to Trafalgar Square, you would find that we had something which would hide Nelson's column.
Now, just how soon do you think we'll be able to get? 60 years?
Oh, I think we ought to be able to get a manned flight to the moon within this century, anyhow.
Well, thank you very much indeed.
Within this century,
Yes.
he was probably regarded as a you know, a forward thinker or slightly crazy.
Oh, we see 60 years, ridiculous.
Yet it was done, what, within 20 years
Yes.
of that recording.
Why did it seem so very far away?
Well, I mean, this was new technology. You must remember that it was probably as common to see a rocket blowing up on the launch pad as actually going successfully. So there were so many failures. So to talk about humans in space and then going to the moon, I mean, it was outrageous.
Yes, yes. But despite the challenges, a growing number of enthusiasts were committed to the idea of travelling to other worlds.
Now, there's one group of people who've come very much into the picture since the launching of the Russian satellite, and that's those who belong to the British Interplanetary Society. Now, some people think that the members of it are too visionary and the society is too premature. But we have one member of the society who has this answer to give.
Well, the British Interplanetary Society most certainly isn't premature.
Who is that handsome young man?
And I think there's a very good parallel to that in the Royal Aeronautical Society, which was formed long before aeroplanes flew.
Although the Sky at Night had been running for around 6 months at the time of this broadcast, sadly, none of the early live episodes were kept, making this, we believe, the earliest recording of Patrick in the archive.
Unmistakable voice.
It is, yes.
And talking as fast as ever, even then.
Well, nobody in the British Interplanetary Society underestimates the difficulties, but they have made very considerable contributions to what has been going on, and in particular, a good deal of the early theoretical work on Earth's satellite was carried out by its members.
That was Patrick Moore, who is a fellow of the British Interplanetary Society, and I must say, Mr. Moore, you're a very spirited protagonist of your society.
But for other astronomers, the very idea of putting someone on the moon was less than desirable.
My name is Fred Hoyle, and I'd like to tell you what I think about it. Roughly 9/10 of the information that comes to the Earth from outer space, information carried by ultraviolet light or by X-rays and so forth, never reaches us at all down here on the surface of the Earth. It gets absorbed in the gases of our atmosphere, so we're forced to live blind, like moles, never quite knowing just what is going on in the big world outside. To overcome these troubles, we'd like to get a telescope and other instruments up above the atmosphere, and this of course means mounting them on a satellite.
Of course, he broadcast quite often in the 50s and 60s, popularizing science and astronomy in particular, and a brilliant mind, involved in some really fundamental work in this time, understanding how stars evolved.
And now, a last point, and perhaps a controversial one, a typical scientist's point of view. No men in our satellites, please. We need all the available space for instruments. Instruments, instruments, and more instruments. That's the scientist's watchword. Men just don't have the right sort of eyes to look out on this new world that's now opening up before us.
So he was sort of anticipating this argument which has gone on for 50 years now, certainly in the science and technology community, the battle between robotic spacecraft and human exploration.
Yeah, because according to him, men had the wrong sort of eyes, so,
well, yes,
so why send them out there?
Absolutely, and this is why we sent X-ray detectors and infrared and ultraviolet detectors initially on the sounding rockets to give us just a few minutes of observation. But of course, he's absolutely right. Most of the radiation which comes from the cosmos is in the form of radiation from different parts of the electromagnetic spectrum, which we just cannot see.
Yeah, we can't. But would you go with the instruments? Because, I mean, maybe a combination or just instruments?
Yeah, no, it has to be a combination. You know, I've made my scientific career based on robotic spacecraft, building, launching instruments to Halley's Comet, to Saturn and Titan, and other interesting places, entirely robotic.
Yes.
So I'm obviously a fan of that. From a pure science element, that's the way to go. But also, one of the things that makes us human, surely, is the desire to explore, and to explore in person to the extent that we can. Physically, absolutely. So you can't curb that desire. So I'm also a fan of going to the moon and going beyond.
Oh, right,
so
yes.
it's got to be both.
Well, thanks, John. That's been an amazing journey through time, and it's been lovely sharing it with you.
It's been my pleasure.
Thank you. As engineers worked on the technicalities of getting rockets towards the moon, the BBC turned its focus to the scientists studying the effects of space travel on passengers. They blasted animals off into space and subjected humans to a more earthbound battery of tests.
You know, sometimes if you're in a lift, and when the lift stops you buckle at the knees, you know you've had this feeling. Well, our astronaut, under certain conditions, sometimes feels very much heavier than he really is, and sometimes he feels very much lighter.
In 1961, legendary children's presenter Tony Hart illustrated how space travellers would be subjected to unusual gravitational forces.
Well, now, last bit of film from me that I want to show you. It's rather exciting because it shows our spaceman undergoing these G forces. In the first instance, he's experiencing very high G. He's on a rotating arm, which is being rotated at extreme speed. There he is looking at his various instruments. He's having to train, you see, while under these conditions. And here are his actual controls. Now, you see the controls are very near at hand. They have to be because he's feeling extremely heavy and he can't move his arms and hands very much. Now, this aeroplane is flying in what is known as a parabolic curve. There it goes, and while it continues on this curve, the people inside it can actually undergo the experience of low G or no G, as in this case, they are experiencing weightlessness. The spaceman is being taught here to accustom himself to this sort of condition. And the instructor is actually swimming in space. And there they're doing it again. I think this is absolutely fascinating. Well, there you are. Girls are doing it too. Splendid, isn't it?
I'm glad to hear it. Yes.
Helen Sharman was the first British astronaut.
Now, you went through astronaut training and been into space, but looking at this training, has much changed? I mean, was this similar to what you did in Star City?
Of course, this zero-G flights, these parabolic flights, are the best part of the training. I mean, everybody looks forward to feeling weightless, especially for the first time, because you really then have an idea what you're going to feel like for longer in space. Quite a big percentage of people typically would be sick on those kind of training flights. So I was lucky, neither me nor the person I was doing my training with was sick, and I think perhaps had one of us been, there might have been a bit of a chain reaction, you know.
Yes, like on the coach at school.
But it is the best bit, really is, and you get an idea how to move your own body. And of course, the first thing you want to do is just to push off from the floor, because there's nothing to stop you from moving, and the trainers know this, so they're physically, they were hanging on to me to stop me from actually just pushing off, and then I'd hit my head on the ceiling. So that's just, you just feel so elated. Yeah, you just want to be cheerful about the whole thing. But the idea is to get us to actually understand how to move our bodies, how gently actually you need to push off from one wall, because you will just keep going until you hit the wall
until something stops you.
Yeah, exactly.
There's also the centrifuge. Was that as much fun or less so? And did you do it?
Yeah, so my centrifuge, I didn't do it in training, but it was part of my selection. And so they were selecting for G tolerance, and then they knew that by doing the physical training and some of the medical stuff that we'd be doing in Star City, that would also help to build that up. But actually, I'm amazingly G tolerant. I had no idea.
But it wasn't just problems with gravity that the astronauts had to contend with. There were numerous tests that went beyond the purely physical. One of which involved depriving the subjects of their senses for several hours.
He is now in a silent world where he sees nothing, hears nothing, and feels nothing. his mind becomes isolated from his physical surroundings. He drifts into a dream state, in which he may no longer be able to distinguish between sleeping and waking, between reality and hallucination. After an hour or so of this, his mind may get so confused that he forgets he is under 3 feet of water. And this man actually tried to take his mask off and had to be rescued by the diver.
There were also tests on disorientation, as a plucky Richard Dimbleby discovered for himself in 1958 by climbing inside this cupboard.
Well, I'm sitting in the box now with my head down as instructed, and I can feel it beginning to turn to the right. I'm doing a turn. I'm keeping my head down. I can in fact count the number of times I've gone round. I think I've gone round about 3 or 4 times. Could be 5 or 6. Looking down at the microphone between my fingers. Only a slight sensation of turning, which now seems to be easing off. Yes, it is. I feel almost as I'm standing still. I know I'm not, because I can see light flicking past the outside of the door. Which means that... Oh my Godfather, so we're going right over to the left. I feel as I'm turning clean over at the moment. That's better. I'm leaning over to the left. Slightly boss-eyed. Now I've got myself straight again. Now I'm looking straight in front of me. And now the box is starting to turn to the left. It's going round left, left, faster, 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 faster. And now it's come to a standstill. Well, when I came out, I felt pretty seasick.
That was an interesting series of tests. I mean, ending up with that last one, I mean, the smirk of that chap at the end. Were they just winding him up and just putting him in a box for no apparent reason? Or did you do anything like that?
So as part of the tests and part of the training, there was a lot of this motion sickness. So the idea is in space, you don't experience the up and the down anymore. So how disorientated will you be? And actually how sick, really motion sick, are you going to feel? So, he said he felt quite sick when he came out of the test, and that can happen.
And that was it, the chap in the water. So there was no feeling.
Yes, although when he was describing it, I thought, well, this is what my yoga teacher tries to get me to think. So I am
mindfulness.
Completely divorced from the whole. But so I didn't do anything like that at all. I think nowadays we recognise, being in space, you're not completely divorced from everything else. You have air, you have vision, you have hearing, and you can actually feel the movement as you move around, as you twist. It's just that you don't feel, let's say, an up and down anymore. You don't, you've not got the effects of gravity, let's say, on you, even though, of course, we know gravity's still there. I know physicists tell physicists will tell me off if I say we were weightless. We felt weightless. Is that all right? I can say that, can't I?
But what sort of person should be subjected to these tests? And the risks of space travel itself. In 1963, Panorama's Robin Day investigated.
These men who have been picked for the exhaustive and exhausting training that an astronaut needs have to be superb physical specimens. What sort of personalities do they need to be ideal space travelers? A leading American space psychologist, Dr. Garottevold, explained to me the characteristics which men need in space.
Well, as you can see by just looking at the biographies, is that they are relatively old.
as far as...
Well, they're between 30 and 40.
30 and 40, yes. But this deviates from our opinion that all the people, the flyers, must be very young, snappy persons who are daredevils and just go ahead. And this is not true for the astronauts. They are mature persons.
They're also married with children. It might seem, at any rate, that this was an odd choice for people going into such conditions of danger
well,
and stress.
Yes, to some extent. But on the other hand, you mentioned the age, and normally any normal male of about 30 to 40 years is married.
Not necessarily. I'm a bachelor. I hope as a psychologist you're not suggesting that I'm abnormal.
Yes, but at any rate, for this type of population, the well-adjusted male is married at that time and also has children.
Do you think there will be any different psychological problems about women traveling in space?
Well, it has been suggested several times that women would make good space pilots because it is said that women have a higher tolerance to a lot of stress and that they can stay pain, for instance, better than men do.
Do you agree?
This may be right under certain circumstances, but not as I see it under the conditions of space flight, because normally the male is the more forceful, aggressive man who is, or subject. He is more vital and he has a higher muscular strength. And I think that this is one of the prerequisites that these people have to have in order to cope with the bodily and muscular stress which is involved.
It's so sad, isn't it? I don't know whether to laugh or cry half the time.
There's a bit of both with it. But he had a very interesting view of the attributes needed by an astronaut. And that was sort of a fairly long time ago. Have we moved on?
We have, thank goodness. I think that the interesting thing is actually there are, I suppose, general differences between men and women. And I would say that there are many women who, if you like, behave like a general man and vice versa. We can talk generally, as long as we appreciate that we're doing that, but we mustn't, therefore, just exclude other sections of
the 50% of the population, as he did there.
So strength is one element, but actually mental strength too, and emotional stability. There's a balance there, and actually nowadays crews need to have a distribution of people and diversity.
Crews are more teams now, with lots of different members contributing.
This is true, and because originally the astronauts were chosen because they were going to be one person sitting on their own, on his own, sitting on top of a spacecraft, needing to be actually very, very reactive. So they were chosen on the basis that they were fighter pilots or behaved like fighter pilots, because that's the kind of people that they thought would make good astronauts. So, of course, those kind of people do tend to be, as he was saying, quite perhaps assertive, the thrill seekers. Why do they want to be fighter pilots?
Yes.
They enjoy the flight. They enjoy pushing things to the limit. Risk takers.
Yes.
They were necessary. But actually nowadays, we don't want people who are risk takers, because if you're part of a team, you don't want to take risks on behalf of your team.
Yeah, the maverick going out on his own.
Absolutely, you're needed. That team needs everybody in it.
It does bring up the rather large elephant in the room of everything is male. All the clips that I've seen today have been talking about sort of men in space, men doing this. Everything is so male-dominated.
And it's a use of that word man as well, which certainly it's to me now, I don't know if it does to you, but it jars.
It does, it's sort of it rings warning bells almost. Yes. Sort of humans, people, but men.
Now I will talk about crewed space flight, I will talk about human space flight, crewed missions, but yes, we talk about, it was all men then.
But also, you mentioned age there as well. He was saying sort of 30 to 40 was sort of the catchment range for his ideal astronauts.
Yeah, so typically astronauts are in that age range because they need to have some sort of experience. By the time they've gone through their astronaut training, they're going to be in their 30s and 40s. So generally they are older. And actually it's no such bad thing to be a little bit older, because if your cells are dividing less rapidly, and the impact of the radiation on you will be slightly less. So yes, it's no such thing. So I was quite young. I was only 27 when I flew, almost 28. I was only 27.
But before they could consider putting a spaceman or woman on the moon, scientists had the important job of keeping them alive in space.
I think we should now consider one of the most important accessories of such a space flight. That is the space suit.
Well, Doctor, that's just what I want to ask you about. This forerunner of the spacesuit developed for the RAF, which we're now going to see publicly for the first time. Just how big a step forward is it?
Well, there's a very long step between the partial pressure suit, which has been shown before, and this particular suit you see now. Perhaps we can have this inflated and you can see the action. See, space is a vacuum and the suit has to be pressurized.
I think it looks like every boy's idea of a real spacesuit.
Can you move around?
If you take it off,
One of the most difficult engineering problems in designing such a suit is to provide an adequate range of physical movement whilst the man is pressurized.
well, I can see you seem to move around all right. Were you uncomfortable? You're sweating furiously now, but were you really uncomfortable in it?
I was a little hot. I think the reason there is that if you are hot and you don't get sufficient ventilation, then of course you just sweat and get even worse.
He's tight. Tight. So, did you wear that?
Not a tie, certainly not.
Here we are outside. Let's look around.
But the RAF weren't the only ones designing spacesuits in the late 50s and early 60s.
I feel that if I were to jump, I'd almost float away. Let's try.
But the BBC costume department seemed happy to come up with its own designs.
Well, that was queer.
The surface of the moon by television for the first time. What a fascinating sight to see this direct for the first time across the face of a moon that looks, I must say, exactly as I, and no doubt you, thought it would look.
Back in 1958, Panorama's Richard Dimbleby visited RAF Farnborough to see how their spacesuit designs were coming along.
In this inner cabin, it's more than the boiling point of water. Without the suit, your blood, quite literally, would boil. Another member of the team showed me a different sort of suit, a pressure suit.
Well, now, would you hold the microphone while I just close your helmet?
Yes, by all means. You must do it vigorously, so that my face is pushing forward. Normally, the air within the suit would do that.
I see.
See it flat. There's a good hard slam.
Here goes.
Ouch.
Open you up again. Is it a fact that when the day comes that a man does walk on the surface of the moon and sees whether they are canals or not, that he will be wearing something like this?
Yes, I think he will. He'll have a suit which surrounds his body. He must be able to move, he must be able to breathe, he must be warmed or cooled. This suit does those things, so any other suit must do the same, and I think must look much the same.
Must look much the
Much,
same,
much
yes.
the same. But I mean, that shirt and tie at the start, no wonder he was hot.
But they are very hot, these. I mean, even now the spacesuits are hot. Though, so only if you're doing an EVA, you're going to go out and do spacewalk, do you have proper sort of cooling garments underneath. So that's the really big difference now. We have two different types of suits, one to do the spacewalk and one to live inside the spacecraft. Because all the Apollo people, they basically had one main spacesuit that was then, and had add-ons to go outside on the moon.
Activities. Right, yes. But there's quite a range of spacesuits there. So the inflated one, and then also yes, and sort of and that snapping on the head, and it just seemed very loose. It seemed a bit plastic on the front.
Actually, I wouldn't like to try and look out of that helmet either. That would be very odd. But the only way of cooling the spacesuits now is to have you have air with pipes that goes all the way down the legs to the bottom of your feet, and air goes down to your hands, and you have little air jets that come up underneath your chin so that it stops the helmet from
steaming up.
Yeah, exactly, from steaming up. It is, but it still is quite hot.
Thank you.
Despite the limits of technology at the time, there had been some surprising progress in the race to the moon.
In September 1959, the Russians landed their Lunik 2 on the moon's surface, not far away from the great 50-mile crater which we call Archimedes. And then in October 1959, just a bit less than a year ago, came that great triumph with the Russian rocket Lunik 3, which actually went round the moon and photographed that part of the moon's surface which we can never see from the Earth because it's always turned away from us.
And on the 12th of April, 1961, the Soviet space program achieved another remarkable first.
Well, I expect you'll realize straight away who this is. Major Yuri Gagarin, just about to report mission accomplished to Mr. Khrushchev, the first spaceman in history. You know, if I'd come on the air in 1957, when we did the first of these Sky at Night programs, and said that within 5 years, I'd be showing you pictures of the first man to go round the Earth in orbit in a spaceship, well, I think you'd have regarded me as mad. But nevertheless, it has happened. And the great question now is, what is going to happen next?
The Russian successes meant that for the Americans, the race to the moon was on. And it received a huge boost from one man.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Broadcaster James Berg was part of the BBC team covering the race to the moon in the 1960s.
So it's interesting there to see Kennedy laying the gauntlet down. But what impact did that have here in the UK?
Well, you have to remember that we lived in the shadow of a potential nuclear war.
Yes.
And the feeling was, I think quite rightly too, that Kennedy's desire to go to the moon was less a desire to go to the moon. Indeed, one of his government said to me he didn't know where the moon was, than to establish America's position as unassailably technologically advanced. So it was primarily a political activity and was seen at the time as that, I think, by most people in Britain. There was an element of, my goodness, an adventure, but back then it wasn't, nobody really felt it was going to happen.
Kennedy's commitment put a rocket under the American space program and led to the establishment of the Apollo missions. It was a huge commitment of resources on a scale that had never been seen before. In a 1963 episode of Panorama, Michael Barrett reported on the spiralling costs of the American quest to land on the moon.
Until recently, this was typical Texas landscape. It was flat cattle country, featureless except for the odd oil rig. But the decision to make this the Manned Spacecraft Center for NASA, the National Aeronautics and Space Administration, this decision started the growth of a great new community. The construction of these buildings alone is going to cost $120 million. And yet that's just a flea bite compared with the national space effort.
The return ticket to the moon for three will cost $40 billion. NASA itself and the contractors it employs require 73,000 scientists and engineers. Is landing on the moon really more important than filling the stomachs of the world's starving? A critical view of Apollo was put to me by one of America's leading scientists, director of the Geophysical Laboratory in Washington and editor of Science magazine, Dr. Philip Abelson.
I've looked to see whether there was economic value in landing a man on the moon, or whether there was military value, or whether there was any other real important justification, and analysis shows that no such justification exists.
Are you saying that man should never try to get to the moon?
I'm sure that man will go to the moon eventually, simply because man is the sort of person that goes to the North Pole, goes to the top of Mount Everest. But The moon has been there a long time, and there is no terrible hurry to go land on the moon.
Are there many other scientists who agree with your point of view?
I would say that an overwhelming majority of those scientists not connected with the space agency hold views similar to mine.
It's quite funny because I'm hearing about this sort of thing. I only really heard about the positive, but it sounds as if there was quite an upswelling of negativity about it.
The interesting thing is the scientific criticisms, which were widespread and not discussed in public. I never met, even at NASA, I never met a hardened geologist who felt anything useful would come back from the moon. I think it was generally recognized that this was primarily a successful political act. That's the most important thing, because we were at war at the time. And in a sense, one might say, historically, that's good enough justification.
Hello. I'm going to attempt a moon landing.
Despite controversy over the investment, the space race sped on. And BBC reporters remained on the trail.
Looks to me as though we're going to crash. That was a pretty abrupt landing. Well, let's see how I made out. Did we crash?
I'm afraid you did. You contacted the lunar surface about 500 feet per second.
And that's how many miles an hour?
Over 300.
It's quite a bump, isn't it?
I'm afraid so.
In 1968, Tomorrow's World reported on the upcoming Apollo 8 mission to orbit the moon and safely return to Earth. And James was lucky enough to visit the Kennedy Space Center and explore the command module.
And this is it. It weighs nearly 6 tons. From top to bottom, it's over 10 feet, and across the base, over 12. It's got 20 miles of wiring inside and over 2 million functional parts. At the top, the docking machinery for latching onto the lunar module. When they do that, a small hatch opens between the 2 small spacecraft and 2 astronauts climb through. That hatch, if anything, could really be called the door to the moon. The door to the spacecraft itself, here. Well, as you can see, inside the capsule there isn't very much room for 3 men, none of whom is shorter than 6 feet tall. Once in space, the position of the capsule itself changes so that what was the pointed roof of the capsule now becomes the nose, like this. Two basic body activities change considerably in space too. For example, the food for the astronauts comes in this form. In a plastic bag. It's freeze-dried, and with a water gun, they inject a certain amount of water, shake it around, reconstitute it, and suck it up through a tube. When they've finished, a sterilizing tablet is left in the plastic bag to kill off the bacteria. Waste products are dealt with differently too. Urine is carried away down a tube to plastic bags and is dumped directly overboard into space. Solid wastes are kept in plastic bags for analysis after the flight. The command module pilot has 3 basic points to watch. The fuel state in the big engines, the presentation of general emergencies, and the fuel states of the small engines of the capsule itself. The commander has 2 presentations to show him whether his spacecraft is rolling end over end, rolling side to side, or weaving through space. And down here, he has 2 controls on the armrests of his couch with which to correct whatever movement goes wrong. And finally, this switch, the single most important switch on board. It turns on the main rocket motors. And if at any time after they get to the moon, that main engine fails to fire, then they don't come back.
So do you remember sitting in the capsule?
Yes, I remember sitting in the capsule. The extraordinary thing about the capsule is it's kind of the size of a VW.
Yes.
But everybody who's been in it in space says it's 3 times bigger when you're weightless.
Oh, yeah.
Because you can go to a little corner somewhere and go to sleep where you couldn't possibly if you were in full gravity.
seeing you in the capsule, it really brings it home. But also, how did you get access to the capsule? Because, I mean, it's feels as if you have a direct link to NASA.
Well, the BBC had a reputation when we got there of correspondents who knew their stuff. So when we got there, we had done an awful lot of reading and preparation, and at the first press conferences, we would ask the kinds of questions like, why is mid-course correction 3 so critical? And they loved those questions.
Yes, the detail.
Because from American reporters, they were getting things like, what does your mother think? Or what's your favourite colour?
Yes.
So the BBC got pretty much free access. Every time we wanted it, it was there.
You mentioned that they liked sort of the detailed questions, but your background isn't in science. So how did you get involved in this whole programme?
Well, at the time, the BBC had just set up its Science and Technology division, and it very intelligently hired humanities graduates to do science and science graduates to do humanities, on the grounds that if we humanities graduates understood something, anybody would, which meant that you always had to talk plain English because that's all you could do. So by the time the BBC started covering Apollo, which is Apollo 7 in 1967, I had worked for Tomorrow's World for 2 years, and that was a science technology show. Not that that qualified me in any particular way, but I came back from holiday one day and the head of the program said, what do you know about rockets? And I said, pointed one end, fire the other. And he said, no, more than that. And I said, that's what I know. So he said, you're in deep trouble because you're covering Apollo. So I rang NASA and said, send every book you've got. And they did, and I spent 3 months doing nothing but reading.
So immersing yourself?
Well, I mean, I did work much harder in preparing for Apollo than I ever did for a degree. You know, so I was well ready when it started.
Large signal, but no voice contact yet. We're standing by.
At 10:36 this morning, Apollo 8 went around the far side of the moon at just over 7,000 miles an hour into complete radio blackout. And when they come out later on in this program, they'll be sending, we hope, live television transmissions from 69 miles above the surface of the moon. And with me in the studio, Patrick Moore. Hello. And hello, Patrick. And we hope to get on to, there's Sir Bernard Lovell at Jodrell Bank.
Apollo 8 Houston, we're beginning to pick up a few craters very dimly. The whole thing is pretty bright.
Along with Patrick Moore, James became part of the BBC's live broadcast team in special programmes covering the Apollo missions.
Patrick Moore, what did you think of that?
Quite incredible. We were seeing things actually as they happened, or rather 1¼ seconds later.
Yes, I'd like to ask both of you if you expect anything at all to come out of this flight that we couldn't have got from sending up an unmanned probe. But Patrick Moore.
I think yes, inasmuch as people have actually done it. And this, I think, is the vital thing. It is an essential part of the programme. I don't think the actual knowledge we're going to get is going to be of fundamental importance, because I'm quite sure it's going to back up what we already know. But if we're going to get men to the moon at all, if we're really going to explore space, then this kind of operation has got to be carried out. And that, I think, is the fundamental point of all this. And it is probably the greatest technological triumph ever made by man.
And this step is absolutely necessary.
And one thing I would like to make here, if I may, there has been suggestions, I know, that this is a mere publicity stunt. This is part of scientific history, James. This is part of our heritage. Yes, and it would be criminal not to broadcast it as fully as we can.
Yes, I see.
So what was it like to be part of the team covering this epic event within the BBC?
Well, there was a feeling that things were exciting and new, and that we were going to be telling the audience stuff that they didn't know because it wasn't being taught in schools yet. So there was a kind of feeling of mission to it. I think there was a feeling that we were all together in bringing something completely new to the audience, which is science and technology. And we felt very strongly that the audience needed to become literate in science, and that was our job, that was our mission. But as I say, we never talked about it like that. This is me being old and pompous now. So we always used to say you could tell how things were going from taxi drivers. London taxi drivers suddenly started saying things like mid-course correction, which they never had before.
Yes, on the way to Bayswater or something.
On the way to Bayswater. I'll just do a mid-course correction down to Hackney Wick, you know.
So it became part of the lexicon, part of the terminology.
Right. Yeah.
Yes.
As the much-anticipated moon landing attempt drew nearer, it wasn't just James and his team that were captivated by the Apollo missions. In an episode of Blue Peter from 1969, John Noakes and Peter Purvis certainly got caught up in lunar mania.
Hello. Hello. Well, this is the caterpillar we told you about last Thursday, and you might think from the look of it that it came off a scrap heap, but it didn't. It's called a lunar track, and it's been specially designed, just like the real moon vehicles, to go over obstacles.
You just get inside and crawl, which is easier said than done, and you steer as well as you can. I'm not steering very well. It was designed by Roger Limbrick, and he made it out of corrugated wood fibre.
You can freewheel down this next bit, right? Can I? Well, it's also very strong, as no doubt you will see in a minute. Oh, you all right?
I think so.
In fact, it's much stronger than Peter, and Peter has collapsed, but the lunar track's still going strong.
And on a more philosophical note, journalist James Cameron pondered the astonishing progress of the space program.
How very strange it is to find that already this extraordinary new business has moved into a sort of mythology, has created its own folklore. Could you believe that in this tiny space of time, less than 10 years, the technology of space travel has produced its own museum? Is it credible that today there should already be veteran spacecraft publicly displayed as interesting curiosities, the old crocs of empty space? And that among these ancient pioneers of only yesterday, there are empty showcases, even now, ready for the rocks and trophies to be brought back from the moon? In this space museum, I personally find it really hard to accept that these prodigies should so soon be embalmed in exhibition, like Lindbergh's aeroplane or Stephenson's rocket. And how strange that today that same word, rocket, is given substance by a scale model of Saturn V. How soon will this too be a curio, a relic, an interesting memento of these primitive groping days when even the moon seemed far away?
And as the Apollo 11 launch day approached, James made a series of pre-recorded films to be shown during the BBC's live coverage of this momentous event.
I have no idea what's going to happen now. I don't know if I'm talking clearly, but pretty soon we'll go up over the top. And when we do, I'm supposed to float. And I'm going. It's fantastic. It's unbelievable. It's the most extraordinary feeling. I can't really control myself. All the dust is flying with me. I'm up. I can't control myself at all. You should see the crew that are filming me, what they're up to. This is fantastic. Look at this. I mean, it is indescribable. And now we're back down again as he pulls out. And I'm sorry, I didn't do any better on descriptions than that, but it's the most exciting thing that I've ever done in my life.
Now, there was a slight groan when you saw this clip was coming on.
That's the worst bit of reporting I ever did. Of course it is. I mean, because there was no way to prepare for it. It had never happened to me before. You know, it's an entirely new experience. I didn't do very well.
I think you did brilliantly, because you got the excitement of it.
Yeah, maybe.
But to me, that's what it's about.
Yeah.
Because I think everybody watching this is sort of, oh, I would love to. I've always wanted to do this, and I've never had a chance.
Yes.
But you sort of give across that excitement of being effectively weightless.
I see. All right then, if you say so.
But yes, so this was a NASA aircraft.
Yes, it was called the vomit comet, because if you've never done it before and you don't, it's not going to be good for you. You vomit, but you can't do it till you're up there.
But fortunately, you didn't.
No.
So this was footage from maybe 1 or 2 parabolas.
Well, we did 4 filming, and then I'd done the story. And then the guy flying the plane said, I'm supposed to stay up here for 4 hours today. I suppose you want to land? And we said, no, we want. So we had 4 hours playing around with these 30-second parabolas, which was extraordinary. And I came back and an American journalist said, what was it like? And I said it was the second most exciting thing I've ever done, and he went on to the next question.
I want to know, what was the first most exciting thing?
Never mind that.
I see. But this was the second, but you couldn't explore it no further.
Yeah, exactly. Thank you.
So this was part of the footage that they used for launch day, I suppose, to show what it's like to be in space. So what were you doing on launch day, and what was it like?
Well, we spent weeks in NASA filming people, interviewing people, doing things like weightless flights and putting on spacesuits and doing whatever it was, so that we had material to fill in the moments when there were no pictures from space, which was very often. Launch itself was one of those journalistic tests. You have to have all the verbals, all the words, blah, 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 what are we looking at, what's it going to do, when is it going to happen, and wait for and build the excitement and all the verbal stuff. And then you had to be very careful not to open your mouth, because once they light the engine, things are said, and they're critical. And if you miss one or you cover one, the audience misses something essential. But when they say those things, it's not necessarily timed accurately. So one was jabbering away, covering the event, but being very careful to shut up if you had to at any time.
There doesn't seem to be any BBC archive of the actual launch. Do you have any theories of what happened? I mean...
They wiped the tapes.
Yes, but it was a pretty epic moment. It seems bizarre.
But, I mean, they had a horse race to cover the next day, I suppose, and tape was extremely expensive and short, And I remember saying to somebody, why didn't you save it? And they said, well, NASA has it all. Yes. So we have every second of what happened on tape from NASA.
Yes.
And it's of secondary importance what I did in the studio, so they weren't worried. What can you say?
Lost to the annals of time.
Indeed.
Yes, thank you.
But for those watching at the time, the sight of seeing someone walking on the moon will never be forgotten.
We were in Paris, and all I remember is going to the Champs-Elysees, and there were crowds of people outside some shop windows watching the landing. I remember big crowds, and we were transfixed watching, not very distinct pictures through plate glass windows.
On small television sets.
On small television sets, but it was fabulous, absolutely fabulous.
I was 6 when Armstrong landed on the moon. And I remember we started doing stuff at school. Yeah. Everything was lunar related.
Yeah.
You would do an art project and there had to be a rocket. If you did a poem, you had to write about the moon.
Although, we know that that whole programme was driven by the Cold War. It was part of global politics. The science that was done was indeed significant. It gave us the ability to collect samples of moon rock and dust and return those to the Earth. And I think it was over 300 kilograms was returned by the Apollo program. And that material is being analysed even to this day, which is quite remarkable. So there are scientific papers appearing in the literature, literally now, based on these samples that were collected 50 years ago.
The legacy, I suppose, is it proves that we can do anything we want to. And I think that probably is the most important thing to come out of the whole thing. We are capable of doing anything we want to once we decide to do it.
The success of this iconic event had a far-reaching impact, not only in America, but also here in the UK. And I think that the sheer drama of the mission, as witnessed by those who were there at the time, has inspired a generation of space scientists, the effects of which we can still see today.
The Sky Night Book of the Moon is available now. Tomorrow night, Brian Cox and Dara O'Brien are at Cape Canaveral for a moon landing special with stargazing at 9. And here on BBC 4, relive the whole historic journey chasing the moon, Tuesday at 8.